We spent all kinds of time beating that like a drum. Well, today we've got what? Oh shoot. So funny. I'll get better. There it is. Okay, we're looking at angle. So, do we have an angle congruence theorem?
No.
No, we don't. But we're not looking for congruence. So we have less restriction here. We can have different sizes. We just have to have the same shape. And with triangles, if you have three sides that are the same length, then they're congruent. If you have two triangles that have three sides that are the same length, it's congruent. But what we looked at in side is we looked at the ratios of the lengths. So when the ratio of a triangle length was the same for all three corresponding sides of the triangle, so you get this one side, the second side, the third side, they all had the same ratio, then they're going to be similar. And all we have to do is we have to look at ratios of side lengths or actual angle measures. So there's a side angle side and there's an angle. But it's not congruence, it's just similar. So we need to have the same side length ratios when we're done looking at them. Let's see if I can do this now. Of course not. I don't know why. This board is different than mine. It's just this board. It behaves a little differently than mine. I'm okay.
It's because it was in Mr. Van Wy's room.
I know.
It's a little different.
It's an English room.
It's in English, yeah. It doesn't understand that.
It doesn't do two-finger drag for me very well.
Do you have to do it on the scroll bar?
You have to do it what?
On the scroll bar, maybe?
Yeah, you can do it on a scroll bar, but it's slow. Yeah, that's like doing this on your phone. Right? Okay, so we have to draw an angle A such that the measure of angle A is 40. So away you go. That's step one. You'll have to read the rest of the steps. All I ask is that you do the labeling, write out the ratios as they ask you to do, because that's going to carry you through the protocols for this lesson. I don't think so. No. Lengths are not a big thing when you're talking similarity. It's the ratio. So we're going to find out whether we come up with the same ratio with the size and such. Yeah, label your 40 and 40, label your point A and A. Says that this is goofy up here. It needs compressed air. No, I don't think it does. No, it doesn't say, does it? It's just that X is creating the ability to have that angle out there. It's not going to be important in terms of our triangle. Just A, B, and C. Oh yeah, before I forget, by the way, I don't know if anyone said anything to you, but what we saw you guys doing yesterday with your effort on cleaning up that area was remarkable. You guys did a really, really good job. yesterday. Yeah, picking up. You guys did very, very well. Did Fulton come walking in here?
Yeah.
And he just set it there? You gotta do some measuring, right? Yeah, I think you do. I do millimeters, then you don't have to worry about making decimal points or fraction marks. So you're gonna use 3, I think. Use 5.5. So I would just call it 60. Because then you don't have to worry about losing your representation. Because then when you round, it comes out. You see it, yeah. I like directions, you know that.
Yeah.
Yeah. Well, I would call that 36, 67. Leave it as a fraction, 36 over 67. Because that's what you're supposed to do next, right? You're supposed to say what it is. It's called 36, 67. I mean, it's 0.5901, that goes on for. 3160.
Yeah, something kind of like.
Okay, 3160.
This is what I was.
61 is the proper. You know you can't. See, they're asking for one more value here, right? They're asking for what that would be if it came up to an 30 decimal, but it isn't 3 decimals, so it is. So what do you have so far? Yeah, those are all those angles and everything, so you're all set. So you have measures. So where are you at in the steps? You've done this, right? So now you gotta write this. So measure, and you measure. So you have, so write AB over DE equals what over what? Actually, they're looking for numbers now. Oh. Yeah, so they're looking for the length of AB and the length of DE as a fraction. So what is that? .83
I was gonna
rough
say,
ten.
yes.
So you could write .83 rough ten, or you could write
I don't know,
like,
it's something I
you
was
could
thinking.
simplify, 30 over 36.
But,
That's one, yeah,
like, triangles, like,
Six.
triangles, like
30 over 36, 15 over 18, divided by 3, 5 over,
like, I can't get them all to have the numerator.
5 over, what's 18 divided by 3? That's 5, 6. Let's go up to.
Yeah, that's their triangles, yeah, but it wasn't.
That's weird, because 5 divided by 6, you should throw 5, 6 up there, I don't know why.
But it is in some kind
Fractions, right? Sorry, I don't know where you calculated that from.
I once had a substitute in an 8th grade class who agreed that all triangles were symmetrical. He left the class while I was gone, and oh my. They liked that substitute.
Oh, so
They
you
said-
were the teacher?
I was the teacher, and the substitute mistaught the topic. I'm like, oh, how could anybody?
But I get it.
Right.
Yeah, and their kids are all similar too, aren't they?
Divided 60 divided by 72.
All squares are.
Oh, it's
Yes, right.
so like, it's like,
That is what I was, but I
Yes.
don't know whether this information is
or online.
It's still.
Have you gone?
Does it
I
have
think it's,
six?
Yeah. Step 6.
I think it's because it calculates
Yes, I just
3
tried
times
that.
there, so it's not a recipe. And that's why it's not symmetrical.
Mhm.
There are other times that you can use that fraction. So, there's a lot down there. What's the other one, you 11, 13? Okay, good, you're on a roll, you're heading in the right direction.
The double squiggle.
You're close, but they're not equal.
Yeah.
So, we get that done, right? So are the triangles similar?
Yes, like that. I got
That would
yeah,
qualify.
yeah, they all changed a little bit, but.
Well, their sides have to have
There's
the same ratios.
one more
Corresponding sides have to have the same
Okay,
ratio.
but the angles are all the same, are they not?
So what were the two sides you were comparing?
Your angles should be the same. Yeah.
So this is.
Okay, so that ratio is wrong. Then what do you compare here? BC, so by that comparison, the ratio of these two sides is different than these two. So I think we come up with it. If this is 40, then triangle, this is different than.
They are not.
Oh, I was in Finland.
Okay.
Yeah. The other pair, BC and BC.
The numbers don't.
Yeah, these are the short ones. These are the middle ones, and these
So
are
you're
the long
supposed to,
ones, right?
you're supposed to, set it up like this.
So 72.
Oh, no, I didn't.
Approximation.
How would that look? AG
If I look at that,
49.
Place approximation?
Honor space?
Yeah.
What does that mean?
When you do the division
what did
calculator,
you write down?
just write down the first two after the decimal point. Or maybe around the second.
62. Well, that's not the one that matters.
How's it going? Your measurements.
Okay, same thing.
Okay. So,
If you handle,
where's
handle,
that?
handle,
About.
then they should.
So this is asking you to write the length of AB
So this is 40.
on top of the fraction,
That's 40. This is
and the length of DB
40.
on the bottom.
I obviously just got it for this. But why did they do like, so here we have A and B, and then this is D, E. Like, those aren't the, like, why are those the length
You
that
don't
are?
have to write
I'm
formulas all the
A,
time.
B, and F, E, because those are the lengths that
So it
are.
almost seems like if I bring them off,
You know, do this divided by that, to the hundredths place, approximately.
call that, no, that's 5/6, isn't it?
Round,
Yeah, it's got, is this a millimeter, a half millimeter, or a whole meter? Millimeter, I think that's what it is.
Does that make any sense?
Oh, your explanation?
Yeah.
Yeah. When you do the measurement.
I can't do that.
but this length is and you take it like this.
I can do it with the small groups.
This length is
But the thing is that
I know it's like obvious and like.
there's a concept in chapter 13 that just allows us to over that or anything. Did we skip that? Have we had it?
It's coming now.
One.
They tell you when
You rounded everything to the nearest.
I'm glad you asked.
Yeah.
You good?
Yeah.
Going up close enough?
So your accuracy line, you did these as decimal, this is 0.83, that's the kind of really.
That's really pretty. This is
And what's 11, 13? Yeah, so there it is, the only thing that's really relevant is you only get your first 2 points. You were accurate with 100, so your measurements were very precise. You get to the near 10, you're close to that. You do millimeters? What happened with yours? When the ratios to the same value? That'll figure out. What about over here? You up there?
Yep, I was looking at the
Yeah, 2.3, that's all good. What about here? 9, 8, 9, and 8, 9, and 9. That's pretty similar.
Where's the local?
5, 9, 5, 8, 5.5. So what do you end up with? Point 7, yeah, that's all. So, that's 6.5, 0.5. Yeah, this is 57, that's good.
I mean, I know what it's supposed to.
Okay, yeah, I don't know, it's hard on paper with pencils. What did you end up with? 7/10 basically? And that first decimal value is what is important, 10th place value. It's 7 2 hundredths, all the way through. 46 divided by 45?
It was like 1.02.
So then you write down 1.02. Then you have 33 over 32, which is going to be 1.0 something also. Yeah, so write it as such. So essentially all of yours come out with a ratio of 1. What's that for the drawing compass? Drawing compass? Which drawing compass do you think?
No idea, I found it on the ground.
Maybe one of the good ones, right? Yeah. How do your numbers look? 999.
See how the last one comes out.
Yeah, so if you just took the first digit, 0.8, we ignore the rest, that's pretty accurate. Yeah. So if you guys are measuring to the nearest millimeter, that's what you get for place values to look at.
Yes.
So it seems like pretty much all of you are right on with that. And then there's also the consideration that Matilda brought up. All three angles are the same angles, aren't they? Individually, they are the same angle. So, you could say angle, 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 and that makes them similar as well. So we've got side, 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 when the ratios are all the same, corresponding, the side lengths of the corresponding ratios are the same. We've got angle, angle, angle for similarity. And there's a theorem. If you want to read through the proof of it, you're welcome to on 757. Probably a little late in the school year to get you excited about that, though, right? You want me to just do it for you on the board? Sure. No way, not a chance. Not on my birthday. I'm the birthday boy. I can do whatever I want today, right? Be the big brat, and then tomorrow it's back to normal. Angle, angle. So, if it was a nice sunny day, we could go out and measure the flagpole like this.
I think we should.
No, we're not gonna go out there.
We can measure.
We don't have any, we don't have a shadow. We need a shadow, so that takes care of that for us, sorry. But if we lived in Arizona, like that nice Saguaro Cactus picture, I don't know what they have on this book here. Let's see. They always have different pictures.
They call this the Cardone cactus.
Yep, here's the Saguaro. Yes. You got more parts? Inside it is. Inside of that eraser. I don't know that these are from the drawing compasses, though. We'll find out. Pointy things. Okay. So let's take a look at the Saguaro Cactus here. So they say, of course, it's not to scale. So they say a meter stick casts a shadow 80 centimeters long. So if it's a meter stick, how many centimeters tall is it? 100 there. There's one piece of missing information. And then this is 80. We'll leave the units out. And a cactus has a shadow 15 meters. How tall is the cactus? So we need to know this. So we're assuming that the cactus is growing at a 90-degree angle, and that they have the meter stick at a 90-degree angle. So what's one way to figure this out? You could set up as a proportion. So how would you want to arrange those three numbers on your variable?
100 over 80, and then x over 15.
Okay.
15 or 19.
So if this is how tall, and then this is how long the shadows are, and this is the stick, and this is the cactus. You said 100 tall and 80 long shadow. The cactus is C and 15. Do units matter?
Yes.
I hear yes, 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 and then I heard no as long as.
As long as they're the same unit.
I'm not sure what you mean by the same unit, because these are two different units. We have centimeters and meters. It's all right. Those things are falling down a lot today. So, keep going. Mary, you started saying?
Did I?
Yeah, I thought it was you.
Make the 15
Yeah.
Okay, if I make the 15 150, if I change that 15 meters to centimeters, no, that doesn't do it, does it?
No.
1500. Now we're going to find out the height of the cactus in centimeters. But a couple of you have said that we don't need to do that. Luke, you were saying we can leave it, or not?
Maybe.
Maybe?
Yeah. Let's try leaving.
Well, let's go and get really labored with this. Put the units in everything. 100 centimeters, 80 centimeters. This is C meters, 15 meters. Aren't those both fractions? Can't we just simplify the fractions?
But then what unit does your, like, overall thing come out as?
If we simplify that by canceling centimeters and canceling meters, we are only working with numbers. And when we're done, C will be a number. And the way this is set up, it will be the number of what we canceled, meters.
So it'd be the number of meters.
Yeah, it's gonna be the number of meters. Okay. Ooh, this doesn't work real well. Gotta be zoomed in or else you can't even read what's on there. Okay. So, as long as what we set up here is the same, and then over there are the same units, we can somewhat ignore them and work with the numbers. Same, if we do this, if these two are the same units, and the numerators are the same units, we can ignore them, because they will all cancel out when we write the proportion, if they don't cancel out initially. So you've got C times 80 is equal to 100 over, or 100 times 15. And then we just solve, divide, you got 10 over 8, which is 5 over 4. 5 times 15 divided by 4, that's how many meters tall your cactus is. So that's one way to do it. What's the ratio of similitude with the meter stick? Take these two numbers right here. Ratio of similitude. Let me finish, okay? Yeah. It's 5/4, yes?
Yes.
Yeah.
No, that's not the ratio of similitude. You're right. That's not the ratio of similitude. The ratio of similitude is going to be the 80 to 15. That's right, it's a ratio between the two. So it's 80 to 15. Yes, the longer to the shorter. Oh, can somebody simplify that for me? I'll make a mistake if I do it.
5 1/3.
5 1/3.
Can you give it to me as just a fraction? 5 1/3 would be, somebody said 16 thirds. So that's the ratio of similitude. So that's what we would multiply the 100 by to make it bigger and turn it into a cactus. So we can take that 16 thirds and multiply it by 100.
Where did you get 16?
Okay,
It'd be 15.
No, 16.
okay, so where did it come from? The 16 comes from 80 by 5.
Why are you dividing by 5?
To simplify this fraction, So we divide top and bottom by 5. So the ratio of similitude is 80/15. We'll simplify it to 16 over 3. And then we take that and we multiply it by the height of the stick to get the height of the cactus. So that's, ooh, yeah, this is where it's bad, isn't it? Mr. Van Wyk told me about this. It's a dead spot. So that's where you get 1,600 divided by 3. That doesn't seem right. What's wrong with it so far? Why does that not seem right?
Why'd you multiply by 100?
Cause that's what the length is for
Just
your
this
stick.
like
I know that where the issue is. Okay, so let me back all the way up. If we do it as a proportion, this is what we have. I'm going to write it a little differently. So if we do it as a proportion, that's what we have. So then in this case here, if we divide by 80, that's 5 over 4. That's C is equal to 75 over 4. Am I doing this correctly?
I think so.
Okay, thank you. Good. And this is going to be meters. How many, let's finish this out. How many times does 4 fit into 75?
18.75.
18 3/4 meters. So that's the height of the cactus doing it as a proportion. Okay, then as a ratio of similitude, comparing the short shadow to the long shadow.
Wait. 15's a meter, isn't it?
Yeah, good, you're thinking way ahead. So what ended up happening is if we have this simplified to 16 thirds,
Well, because it's not the same units on the same fraction, right? Isn't that centimeters over meters?
yeah. So 16 centimeters results in 3 meters.
Yeah. So then would it be like 15? Yeah, okay.
Okay, so then if you took that and multiplied it by 100, that's in centimeters, isn't it? So what should be done back here to come up with a ratio of similitude? What are you saying, Titus? Yeah, change the meters into centimeters. So if we changed 80 centimeters and 1,500 centimeters, then that's 8 over 150. Can you keep simplifying that?
Yeah. 4 over 25.
4 over
Oh,
75.
75. Ah, good, look at this. That's going to be more helpful. So this is the ratio of similitude. If we multiply by this number, we make the size smaller. If we multiply by its reciprocal, we make the new number larger. So if we're going to go from a small stick, ooh, that's not good. If we're going to go from a small stick to the larger cactus, which of these two would be the right one to multiply by? The bottom one. Now, that's centimeters. This was meters. So it's just going to end up being that many centimeters And then we can change it back to meters, and it's gonna be the same number as this. So we have to divide by 100 to change it from centimeters to meters. Ooh. Which do you like better, ratio of similitude or the proportion? Good, I do too. A lot more. Yeah. You want to erase this?
No, if I may,
Go.
I'd like to clarify how you could have used the 100/80 thing.
Yeah, okay.
Which is it's the height to the base of the smaller triangle. If we called that 1.25, yes? What that's saying is, if you start with this and you multiply by 1.25, you get that. So if we start with 15 and we multiply by 1.25, we get what we need.
So there's a third way. Yeah.
Okay, and I can do this. One,
4 point.
right?
How tall is it? 4 1/4 meters? No.
It's 18.7.
18 3/4 meters. Yeah. There. That was the fastest way. There's lots of ways to look at it.
If you're gonna assign them anything, it should be very short.
Really?
Yeah, we haven't given them any work time.
1 through 33 all?
And
Oh,
Yeah.
how about since it's Mr. Dagan's birthday, there is no homework.
So he doesn't have anything to grade.
Oh.
We're thinking ahead.
You're thinking.
We're looking out for you, Mr.
yeah,
Dagan.
there's more to this lesson
Yeah.
that we really should do in class.
Should we do 2 through 7? 2, 3, 4, 5, 6, 7.
No. No.
2 through 7. Well, I've got 9, 10, and 12 through 14. But 2 through.
We can do that tomorrow.
Sure.
Yay, birthday boy.
2 through 7 on which page?
Where is it at?
Yay for you guys.
Oops, don't want that. There it is. Page 760, I think. I don't have anything in for tomorrow anyway, so that's all
What's
good.
our, like, next quiz for this chapter? Next
Tomorrow.
Quiz.
Jay's not giving him
Quiz.
ideas.
Quiz.
Do we have a place tomorrow?
No.
Oh. Quit giving him
No
ideas.
quiz
Quit
tomorrow.
giving him ideas, Koa.
We should measure
Keep your
our
mouth
longest
shut.
hair for homework.
Measure your longest hair. In centimeters or meters?
Centimeters.
I have
Yeah.
the,
You sure you don't want to just shove it in your book?
no, I have one at home that I'll bring.
Okay,
Yes.
thanks.
I'm keeping mine in my book.
Yeah, 2 through 7. 3 sufficient conditions for triangles to be similar. One of them is
Angle,
side, angle,
side.
side. What's another one?
Angle.
You said side, 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 and angle, angle. Yeah, I mean, 7 is pretty, or 3 is pretty friendly. So you, just for 3, 4, 5, and 6, you're just saying whether they're similar, and what is the theorem that guarantees it?
Yeah,
Well, you're not proving anything, Koa. You're just stating them.
He's got like a rubber arm there.
Who does? Koa?
Oh, show us.
Theorem. You like
I'm
theorems.
watching you now.
Yeah, that doesn't work. So what's the theorem that the third one?
Angle.
Well, they say J and L angles are the same, right? Do they say any other angles are the same? But can you justify that another pair of angles is the same? So you're talking about the big triangle and the triangle which is smaller within it.
Number 3 you're talking about?
Yeah, 3.
Okay.
Oh, we're past it. I think.
Yep, keep going.
This is the previous, oh, there it is. Yeah, that's it. So you have one angle. Is there a second angle? Take MIJ and pull it off of here. And then you have MFL as the other triangle. Yeah, so M is the same. Right, Jacob?
Thank you, Mr. Dagan.
You're welcome. Come see us again.